Hello, I'm Nathan, I'm Adrian, I'm Carlos, I'm Jonathan, I'm Juan. Welcome to our group video. We went to the Griffith Observatory in LA. Have you ever been to the Griffith Park Observatory in LA? It's more than just a pretty view. It's a symbol of accessible science education. The story begins with Griffith J. Griffith, a wealthy industrialist who donated the land to the city in 1896, envisioning a public observatory. His goal was to make astronomy accessible to everyone regardless of their background. It opened in 1935 and quickly became a landmark offering accessible astronomy education.
Now let's talk about rocks. Sandstone is one of the most common sedimentary rocks you'll see in this region. Sandstone forms when layers of tiny sand grains are pressed and cemented together over millions of years. Now, when sedimentary rocks like sandstone are buried deep underground, where it's really hot and under a lot of pressure, they can transform into new rocks. This process is called metamorphism. Through metamorphism, you get beautiful rocks like schist and gneiss. These rocks are special because their texture and minerals have changed dramatically. The grains get bigger, minerals align into patterns, and the rock becomes much tougher and shinier. That's not all. Some rocks are born from fire. Igneous rocks like granite and diorite form when magma cools and hardens beneath the surface of the earth. Granite especially is easy to recognize because of its light color and big crystal grains. Can you guess what type of rocks these are? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Number 7 is meteorong. Number 10 is meteorite. Number 3 is also meteorong. Number 9 is meteorong. Number 2 is meteorite. Number 12 is meteorong. Every rock you see, whether it's sandstone, schist, gneiss, granite, or diorite, is part of a new-ending cycle. Rocks get broken down, buried, melted, or squeezed, and then reappear in new forms over and over across millions of years.
The Griffith Observatory is in an active seismic zone due to its location near the San Andreas Fault. The movement of tectonic plates causes stress to build up in the Earth's crust, leading to earthquakes. The observatory's location in the Los Angeles Basin makes it susceptible to ground shaking from these events. Did you know that Los Angeles sits on the edge of the Pacific Plate and North American Plate? These plates are constantly moving and interacting, causing the frequent earthquakes in Southern California. The San Andreas Fault is the main fault line, but there are also many smaller faults in the region. These faults can rupture and cause earthquakes too.
A local fault line is visible near the area. It's a right lateral strike-slip fault, meaning the two sides of the fault slide past each other horizontally. This is caused by collision and grinding of tectonic plates. The folded hills and steep hill drops are all signs of the mountains shifting through faults. The San Andreas Mountains have been uplifted by tectonic compression along the Pacific North American plate boundary. It was a right lateral transform fault. It illustrated show how the Earth's tectonic plates shape our planet. To show this, here's a video that shows tilted and offset features in the mountains. These steep hills around Griffith Park are a result of crust being pushed up over millions of years by underground fault movement, especially from nearby faults like the Hollywood Fault.
Fun facts. The largest tectonic plate is the Pacific Plate, which is responsible for 90% of all earthquakes. The processes in the rock cycle like weathering and erosion take place over incredibly long periods, often millions of years. Faults can be at any angle and their movement can be vertical, horizontal, or a combination of both, which is called oblique slip.
Thanks for watching.